Hello, everyone. My name is Isabel Troncoso. I'm from the University of Lisbon, and I have the great pleasure and honor of introducing our next speaker, Mari Ostendorf. Mari joined the University of Washington in 1999. She's an endowed professor in the ECE department and also an adjunct professor in linguistics and in computer science and engineering and associate vice provost for research. She's a fellow of the IEEE, of the International Speech Communication Association, and of the Association for Computational Linguistics. Also a former Australian-American Fulbright scholar and a member of the Washington State Academy of Sciences. All these awards show how Mari excels as a researcher, but I would also add that she excels as well as a teacher and advisor. In 2017, she served as faculty advisor for the student team winning the inaugural Alexa Prize competition to build a social bot, and conversational AI is the focus of her current work. Her research explores dynamic models for understanding and generating speech and text, particularly in multi-party contexts, and it contributes to a variety of applications with great societal impact, from education to clinical and scientific information extraction. So far, I've been mostly reading from the bio that one can find online, but I would like to add a few words of my own. Mari has advanced the field of speech and language processing by combining pioneering advances in statistical modeling and machine learning with an understanding of the deeper structures in speech. For these contributions, she was also the recipient of the IEEE James Flanagan Speech and Audio Processing Award in 2018. I cannot understand how she leaves that out of a resume. And she also has an extremely extensive record of service to the community, from which I would highlight being editor-in-chief of the IEEE Transactions for Audio, Speech, and Language Processing, vice president for publications of the Signal Processing Society, and being the first editor-in-chief of the IEEE Open Journal of Signal Processing. So I hope that those of you that are not so familiar with Mari's work as I am, after this talk, will share with me the greatest admiration. I leave you with Mari.
Thanks very much as well. It's a pleasure to be here, and I really look forward to chatting with people online.
Yeah.
I'll play the video now.
Good morning. I'm Mari Ostendorf from the University of Washington. I'm going to be talking to you today about processing spoken language. Now, I know you've had a very full schedule and you've learned a lot about NLP, but most NLP work has been done on written text. And spoken language is a little bit different and introduces some complications. You can't just treat it as a different genre of text. So that's the key message for today. Now, there's been a lot of growth in speech devices that you can talk to and in the presence of audio online. Why is that? Because people like spoken communication. Video and podcast content is rapidly growing online. People like to listen to things. It's often easier to talk than to type, especially while you're driving or cooking or have hands busy in other ways. And lastly, speech technology makes information more easily accessible. Now, the key reason for this growth is really that speech recognition and synthesis technology has advanced. And so it actually works pretty well now and is easy to use. However, the current technology mostly is not doing understanding. There's, or certainly not much understanding. There's simple commands, there's transcription, voice search, but what's next is really spoken language processing, combining speech and NLP, which have both advanced with many of the same neural models. So if we can combine speech and language, that's going to enable speech interfaces for more complex tasks. Also, it will make it possible for speech and video to be as accessible as text is now online. So the idea is we'd apply NLP algorithms, NLP tasks to spoken language. So videos can be summarized, speech can be translated. One could think of a video or a podcast as a document from which we can extract information, answer questions. And then, of course, there's chat and assistant dialogues, for which voice is perhaps a more natural way of interacting than text. So now that I hope you are interested in hearing more about the differences between processing text and spoken language, I'll just quickly outline what I'm going to talk about. First, I want to talk a bit more in detail about how speech is different from text and how it's not just noisy verbalized text. Then I'll go into a couple general challenges in applying NLP to spoken language. And then a third challenge, which is specifically related to dealing with conversational systems. Lastly, we'll close with a brief discussion of ethical and social issues. Now, it's easy to think of spoken language as just noisy verbalized text, but that's an oversimplified view. And there are 4 different things that are reflected in the differences. One is imperfect speech recognition, of course. In addition, there's disfluencies, the fillers, repetitions, etc., that we say in conversational speech. There's, of course, style differences. And lastly, there's extra information communicated in speech through emphasis and intonation. Let's talk about each one of these. So even now, with the great advances, ASR is still imperfect. There's a few reasons for that. There's possibilities for error because we miss or misdetect speech, creating words when they're not there or not intended, or missing words. There's word recognition errors, of course, but also there is a lack of sentence segmentation. So you're just getting a sequence of words and you don't know necessarily whether there's 2 intents or 1 long sentence. So what I've included here are a couple examples from when the UW team participated in the Alexa Prize SocialBot Challenge a couple of years ago. And of course, speech recognition has improved since then, but I believe it still doesn't work so well for children. And children do talk to these systems. So the first example, I don't know that we don't have the audio, but my guess is it's a kid talking about their pet hamster. In the second example, there's more than one phrase here. And the one that we actually probably got right is the "that's cool" at the end. In both of these cases, you run into problems when you have errors that there's not a lot you can do with it. And systems have to have generic responses or error correcting responses. The second example that's often raised when talking about speech is disfluencies. So I'm going to play a little snippet of a conversation, and it's fairly representative. It's particularly disfluent, but it's fairly representative of how people talk in casual conversations.
Where I did it the other day, it was the pork ribs and the bunch of Korean food and stuff. But yeah.
So what we take away is a cleaned up version. We mentally sort of filter out the disfluencies and get, what did I do the other day? Oh, the pork ribs and a bunch of Korean food and stuff. Yeah, I don't know. Of course, we actually don't totally filter them out And we do take advantage of them in recognizing cognitive states, somebody thinking about something, remembering something. We also use them in turn taking. So the disfluencies are not just noise. They actually have information for dialogue systems. Now, you may think that disfluencies are just a problem for conversational speech, and there's a lot of applications other than conversational speech. But in fact, for all forms of spontaneous speech, people are disfluent. So even in high-stakes Supreme Court oral arguments, people are disfluent, both the justices and the lawyers. And even children are disfluent, starting from a very young age. They learn these patterns from their parents. Another obvious difference is style differences. Spontaneous speech is more informal. Commands to assistants are simpler. It's very different from a lot of the written text that NLP is designed for. And to illustrate differences, I've started with a Wikipedia example. Longer sentences, complex noun phrases, more adjectives. It's a good example because this is what a lot of natural language processing word vector representations are trained from. The second example is a blog post. So written text that's more informal. And it is different. It doesn't have the same sort of grammatical formal structure of an article, but it does not have the same informality and back and forth that you would see in conversational speech, which is illustrated in the third example. So this is another snippet of that same cooking conversation. And in this example, you see there's much simpler language. There's a lower information rate. That's common in spontaneous speech. There's a need for grounding conversation. So effort is put towards that, corrections, and more questions when you have spontaneous speech. Finally, we come to prosody. It's not what you say, but how you say it. In this example, we illustrate the contrast that can be created with emphasis and phrasing. So a mother is asking her daughter to be nice to her sister and compliment her but the daughter takes the same word sequence. Why don't you look nice? Which is a compliment, and changes it to, why don't you look nice? Which is a criticism. Difference being indicated in the text through setting off why as a discourse marker. In speech, it's set off by emphasis and intonation and phrasing. Now, it's easy to think that these are anecdotal examples, and do they really matter in real applications? Well, my experience is that in conversational speech, conversational systems, you see them a lot. So you may want to, and there's a variety of ways where prosody plays a role. You may want to use it to determine whether the person is actually talking to the device versus to somebody else in the room, or are they finished with the turn? They may be hesitating and thinking. It's useful for sentence segmentation, determining intent. For example, questions in spontaneous speech are often presented in statement form and just indicated with the final question rise. There are a lot of frequent words that have different meanings indicated by prosody. A very good example is the word yeah, which could be used as the answer to a yes/no question, could be used as an agreement, it could be used in back channeling or turn taking, and lastly, there could be sarcasm. We see this a lot in social bot dialogues and also in human-human conversations. So in this particular example, one that we did not handle correctly, the answer to the question is no, but the person starts out by saying yeah to acknowledge that they're interested in the subject. Another great example is the word "oh." People say "oh" in a whole bunch of different ways to communicate a range of intents and sentiments. So first, we'll look at the "I get it" example we'll listen to.
Oh.
And next, an "I remember" example.
Oh.
And then there is the "of course."
Oh.
Lastly, the unenthusiastic acknowledgement.
Oh.
Now, there is somewhat of a lack of success stories for using prosody in speech understanding, despite the fact that it seems like it should be important. And we know it's important in speech synthesis. So what's the problem with speech understanding? Well, I think there are a few good reasons. The first is it's a hard computational problem. Prosodic cues are associated with multiple phenomena at different time scales. There's speaker effects. In synthesis, you have to deal with one person. In understanding, you deal with multiple ones. It's hard to disentangle all of this. Secondly, a lot of the work on prosody was done in red speech. Red speech doesn't carry the same sort of information in prosody that spontaneous speech does. Red speech is very different. And here's an example. So here's spontaneous speech.
Yeah. Yeah, I've noticed that's one of the first things I do when I go home is I either turn on the TV or the radio. It's really weird.
And then the same person was asked to come back and reread what they had said.
Yeah. Yeah, I've noticed that's one of the first things I do when I go home is I either turn on the TV or the radio. It's really weird.
Now, this is an exaggerated case because it's very hard to read your own disfluent transcript. But it is a case that the prosody of red speech, even fluent red speech, is less communicative. Lastly, in a lot of prior work on speech understanding where ASR was not as good, the words just matter more. And so improving ASR has given greater benefits. And secondly, because the ASR wasn't so good, the prosody of users talking to the system often reflected their uncertainty. And that sort of uncertainty comes across sounding like a question. However, now with the major advances in speech recognition, it's worth revisiting prosody.
Yeah.
So this brings us to the marriage of speech and language. To build a human-computer dialogue system or to process archives of conversational speech, we need to combine both speech recognition or synthesis and natural language processing. But I've been trying to argue that because of the differences between speech and text, spoken language processing requires more than simply throwing words over a fence. It requires a marriage. In speech understanding, natural language understanding needs to know information about recognizer uncertainty and the prosodic information that's carried in speech. On the generation side, natural language generation needs to provide intent information for controlling prosody. Otherwise, it's just going to sound like a dictation. That brings us to two important challenges, general challenges, in applying natural language processing to speech. So the first one is domain mismatch. And I'd argue that this is a bigger issue for speech than text, because spoken language data is more costly to collect than text, because you have to get both the word transcriptions and whatever annotation, meaning annotation you want. And secondly, there's more variation in spoken language because you have both the speaker has a choice of changing words, but also changing the prosody. The second issue that I'll talk about is acoustically marked structure, and that's related to getting the prosody. We'll focus on disfluencies and segmentation, but there's clearly more types of structure that it marks. And the key challenge here is in integrating word and prosodic cues. Now, I'm sure you've heard a lot about how natural language processing benefits from pre-trained word vectors. It's very well established now. And the best thing to do tends to be represent a word sequence with contextualized word embeddings. So the idea is you learn a language model and the hidden state of the language model represents a word in context. That could be an RNN or it could be a transformer. And these can be learned just from sequences of words, so it's effectively unsupervised learning. So the idea then is you use a vast amount of text to learn a general purpose embeddings, and then plug those into whatever task-specific network you have that has the annotation. When there's a domain mismatch, which is often going to be the case, you fine-tune the language model or the last layers of the language model, transformer, whatever. Now, informality of speech can be thought of as a domain mismatch problem. And so that raises a question, is written text, if you think of it as a different domain, a more general domain, is it useful for parsing speech? Well, if we're thinking about tree-banked Wall Street Journal annotated text, turns out it's not really so good. There's a big difference looking at parsing. But again, looking at in parsing studies, a large amount of general text actually is helpful, of course, only when you use fine-tuning. So we can get, if we just use written text, then, but a state-of-the-art neural parser, then we would get an F1 score of, say, 77. If we use only conversational speech transcripts with parses, that would be Switchboard, then we're up to 91. That can be improved a significant amount using embeddings, bird embeddings. And, but the difference when you add back in the tree bank training, it's not much. So the thing that's really helping is the large scale unsupervised training. Now, it turns out researchers, general purpose embeddings only go so far, and if you have a specialized task, you can do better with specialized embeddings. So researchers have trained embeddings like SciBERT, BioBERT, ClinicalBERT for these types of applications. Unfortunately, there's not yet a lot of accurately transcribed publicly, or even transcribed, publicly available conversational speech for training a conversational BERT of the order there is in text. Now, in commercial companies, they probably have access to that quantity of text. But for those of us in academia, it's not there yet. So it's an open question. So while it's good to have a conversational BERT, we don't have it, and it's still an open question whether that should be accurate transcripts or ASR. So there's some work to be done there. Switching gears, I'm going to now talk about acoustically marked structure. So starting with a very simple way of representing structure, we can think of both disfluencies and sentence segmentation as a BIO word tagging, begin, inside, outside word tagging problem. So the first example illustrates disfluencies. I want to have the BD with beginning of disfluencies, then I'm in the disfluency, then I get to the end of the disfluency, then I'm at the beginning of the correction, and I move along and I get another disfluency, and I get the rest of the correction, and then the other would be the fluent text. The second example illustrates sentence segmentation question, and this was actually its example, and this was actually a sequence of 2 questions, and so I did begin question, inside question, end question, as to indicate the structure, sentence structure of this example. Now, if I was to do a word tagging problem, I'd start out with mapping the word sequence to a sequence of word embeddings. And that actually will work pretty well for these 2 tests, both disfluency detection and sentence segmentation. But it works pretty well for the simple cases. When we get complex disfluencies, sentence fragments, and trickier examples, it does not work so well. And you could say, all right, well, let's just use the pauses, and that's good enough. Pauses are ambiguous. They mark hesitations, as well as disfluency interruption points and sentence discourse structure. So what you really need is prosody vectors that incorporate pause information with other prosodic cues. So let's talk about the other prosodic cues. So what typically you have with prosody is fundamental frequency. You need a representation of vocal effort, so some energy or spectral features. And lastly, timing. So in addition to the pauses, word lengthening plays an important role. The problem with extracting this information is that different phenomena occur at different time scales. So word emphasis would occur in the word. Topic change, segmentation, or disfluencies really get marked at word boundaries. So they affect word endings and onsets. If I have an aside, well, a parenthetical, that would be marked with phrase level pitch change. And lastly, indications of emotion and attitude impact whole segments and word-specific tones. So it's both scales. So to handle this, we really have a multimodal integration problem. We have the text and we have the acoustics. And to communicate why we need to do this, I think it's useful to have an analogy with image captioning. So the caption and the image, the text associated with caption and the image, have both complementary and redundant information. Just as words and prosody have complementary information and redundant information. So an image could have multiple captions, and one could imagine associating the caption with the bounding box. So if I took this image and crowdsourced it, I might get a simple caption like girl playing with the frisbee, and the bounding box would pay attention to the girl. Of course, if you happen to know where this image appeared, it's like you happen to know who's speaking a sentence or the social context of the audio, then that would change the wording. So the bounding box might be the same, but the wording would change. And in this case, name the player. Or it could be that you're interested in the person taking the video, who is the player's father. Or if you really know them, you'll know that he's famous for doing this on a ladder. So basically, the boxes communicate where the focus of attention is in the same way prosodic emphasis communicates focus of attention in a sentence, and thereby can change the meaning. And of course, in addition to that, we have phrase structure and other types of information in prosody. So if it's a multimodal integration problem, you have standard multimodal integration issues. how tightly coupled the modality is, and that reflects this whole timing issue for prosody, but also the modality representation learning strategy. For the sentence understanding tasks that I've worked on, we use word-aligned prosody vectors, but we have looked at different representation learning strategies, including both parallel and conditional encodings of prosody. So the first example uses a parallel encoding, and this is actually moving beyond tagging to parsing, but the same idea applies. We're going to combine a word vector, concatenate it to a prosody vector. In this particular case, we use a convolutional neural network to learn F0 and energy features, and that network has filters that span different timescales to be able to learn different types of phenomena. In this case, we had a separate mapping for pause and duration embeddings. Those all get concatenated, added to the word embedding, and they are trained in an end-to-end fashion together with the word embedding and the parser objective. Now, in this particular study, again on Switchboard, we used given sentence boundaries and known word transcriptions. So hand word transcriptions. And so there's a little less of an opportunity to show a benefit from prosody because the sentence boundaries are an important place where prosody helps. But even still, we get parsing gains, particularly for disfluencies and verb phrase attachments. In other tasks, there's been more of a challenge in getting a gain from prosody because of the redundancy between prosody and the words. And in that particular case, a lot of the effort of learning the prosody features is somewhat wasted because the words are there and they're reliable. Now, it's robust to have that redundancy, but if the words are pretty reliable, we might want to learn the prosody cues in a different way. So this is our contextually normalized approach to learning prosody features. The idea is, given a text, we're going to predict its prosody. Once I have that prosody, I'm going to compare it to the true signal and look at what is the difference relative to the expected variability. And I'm going to call that result prosody, the resulting prosody features as innovations. And that's because what I'm actually doing is not just predicting the prosody, but I'm predicting a distribution of the prosody. So what do I expect the duration of the pause to be at this location, after this word? What do I expect the duration of the word to be? What do I expect the distribution of fundamental frequency to be? Then when I compare that with the true signal, I compute a z-score. So this is like the z-score that people have often used in prosody modeling of duration or of intonation speaker normalization. But in this case, the context normalization is actually based on the whole word sequence, not just the local context or not just the global context, it's the word sequence context. So we call these innovations, and they represent the variation that's not accounted for by the word sequence. So the differences from the default reading. Using this prosody representation in disfluency detection for Switchboard, we find just what we want to find, that words are longer and have lower energy when they're right before interruption points, as has been observed in linguistic study. But more importantly, that these cues actually work better than the raw acoustic cues, duration, pause, fundamental frequency. So in fact, very different from previous work, we find these innovations are almost as good as text alone. Now, of course, they're based on text, but most other work has used prosody features with normalization based on text. So this was a pretty exciting result. In addition, when you combine the prosody with the text, you get further improvement. And the examples where prosody helps reflect the places where there are ambiguities where prosody should help. So for example, when you repeat a word, most of the time, a word repetition is associated with disfluency. But sometimes you repeat a word for emphasis, as in this case. But it's just, you know, leak, leak, leak everywhere. In other examples, there's ambiguities of whether something is fluent or disfluent. And knowing that there's prosodic cues can help you determine whether there was disfluent. So in this case, it was it is perfectly grammatical and fluent, but what the person said was it was it, so that was actually a disfluency. Now we'll turn to conversational speech, which brings in new challenges. The last two things are general for all kinds of spontaneous speech, podcasts, etc. But with conversations, things are a little bit more complicated. So I want to start by talking about why you should even be interested in conversations. Then I want to emphasize that conversations are not documents. And then I'll go into individual differences between speakers, which is important in conversations. So why conversations? Well, people like spoken interactions. Web-based chat and frequently asked questions have not replaced call centers. I've been working on call center data, and that's challenging data. ASR has not solved that problem. And they have lots of issues that speech understanding could help with. Informational audio is often interactive. So interviews, debates, hearings, lectures with Q&A, all of that is interactive and tends to have conversational components. And lastly, in this difficult time of COVID-19, where we need to be socially distanced, we continue person-to-person meetings and social events virtually. And so it is important. The interactive action part is important. It's useful for learning, it's useful for problem solving, and it's useful for team building. So I am convinced that conversations are the next frontier. Virtual assistants are already becoming more conversational for constrained tasks. There's nice demos out there. There's also potential impact in many application areas. So call center support, interactive tutorials, working on a project with for dialogic reading to help with early literacy, virtual companions and personal robots, conversational speech translation, and meeting summarization, medical diagnostics, the list could go on. Importantly, a conversation is not a document. So much technology now is aimed at things like summarization and question answering of documents. And documents are a linear sequence of sentences. But conversations involve multiple people talking. So there are speaker differences that have to be tracked. And they may interrupt each other. They may talk over each other. They may back channel when somebody else is talking. They don't necessarily respond to the previous utterance. Sometimes they respond to earlier utterances, and people finish each other's sentences, so it's all over the map. So this little graphic here is the speaker talking times of an actual meeting with several participants. So it can be very nonlinear. And to handle that, it's useful to think about conversations having graph structure. And this is true both for online discussions as well as in-person conversations. In online discussions, you have threaded discussions. Somebody makes a comment, other people reply. You have the structure of who's replied to who, but also the order of when these comments came. So there's both reply to links and temporal links. For an in-person conversation, or a phone conversation also, there's the link between who's talking and what they're responding to. So there's a cross between people links and within people links. Now, one way to track this, to represent these different types of links is to have a speaker state tracker and a dialogue state tracker. So the speakers contribute to the dialogue state alternately, or when they have their turns, and we keep track of the speakers separately. Now, why would you want to keep track of the speakers? Well, they may have different roles, like a host or a guest in a talk show, student versus expert, agent versus customer in a call center. And with those roles, they would say different things. They would also have different interaction styles. But even when you have within one role, the individual differences of people give you different interaction styles. So here again is an example from our Alexa Prize Dialogs. On the left-hand side, we have somebody who talks a lot and wanted to contribute a lot to the conversation themselves. On the right-hand side, we have somebody who's very terse, who is interested in hearing what the system has to say. They're happy with communicating, talking with the system, but they don't want to say too much themselves. And I'm sure you all know people in these two different categories from conversing. In addition to that, if you are building a conversational system to serve somebody, the people are going to vary in terms of their interests. Also their abilities, and of course their sense of humor. So another example, we had things that we pulled from Reddit discussions that had funny comments. So this was intended to be amusing. The comment is, did you know that Malaysian vampires are tiny monsters that burrow into people's heads and force them to talk about cats? The reactions to this comment were quite varied. Some people thought that it was funny, as we had hoped. Other people thought it was creepy because they didn't actually really pay attention to it, or that it was interesting. Then there was somebody who knew it was bizarre and didn't think it was funny. What the heck? And lastly, there were the cat lovers. Now, we can see it could be useful to have a speaker state tracker. And there's two types of information we're going to have to keep track of. One is the short-term modes reflected in the conversation. Is the person satisfied with the interaction, for example? And the long-term factors reflected in what they're talking about, the person's interests overall, etc. So the speaker state tracker kind of plays these two roles. Keeping track of these two different things is rather useful. It's rather useful to use something like an LSTM neural network to have some long and some short-term context. Now, the input to that network is a representation of the utterance, and there's a lot of different ways you could do that. Oops. You can use BERT embeddings or whatever. What we chose to do is have a representation based on latent user modes in order to have it be more interpretable. So basically, you take the utterance, the local text context, and apply it to create attentions against a dictionary or memory, and make the representation of the utterance a weighted sample. To train this, Rather than using annotated data, we just use conversations and do next utterance prediction to provide an unsupervised pre-training signal. Now, speaker state tracking actually can make a difference put on top of dialogue states using this unsupervised pre-training. We've used it in 4 different types of tasks: Reddit discussions, popularity prediction. It's the social bot chat, the LX prize problem. And there we're looking at, will the person accept this topic? So modeling speaker interests. Human-human conversation, dialogue tagging, and there it turns out that you're learning more about what's been the characteristics of the dialogue, what types of people do in response to different types of dialogue acts. And lastly, in task-oriented dialogue, multi-domain state tracking. What we learn in these speaker modes varies in these tasks, but we generally learn topics or topic interests, sentiment, politeness, and lastly, coarse-grained dialogue act. Now, the important thing about conversations is evaluation. It is a huge open problem. The fact that conversations are interactive and that there are individual differences of users poses a lot of challenges for evaluation. For most tasks, there is really no gold standard conversation. Once a human is in the loop, the conversation can go anywhere. And many responses are perfectly acceptable. They differ with different people. So when one uses a single reference turn level scoring for generation, it's not as people do with using blue or rouge, et cetera. It often doesn't correlate well with human scores simply because of the allowable variability. And again, responses that are acceptable to some people are not to others. So there's no easy answer for this right now. It's an open problem and an important challenge to come up with automatic metrics. In the meantime, it's critical to supplement all automatic metrics with some sort of human evaluation. Now, when we talk about individual differences, this brings up this issue of spoken language being personal. And it's more than just about tracking interests. It's about the speech. Advances in speaker recognition technology make people identifiable from their speech. And false trigger of hot word detection can expose personal information. In addition to this, there are concerns about speech synthesis technology being so good that one could spoof systems with voice theft. All of these are really valid privacy concerns. They also make research more difficult. Because of the privacy concerns, commercial ASR systems don't expose the audio. So that means no prosody features. It also limits data sharing, which limits the potential for learning and for duplication of results. Putting all this together, I think it's really important to recognize that conversation technology will need to leverage advances in privacy-sensitive signal processing, privacy-sensitive learning, et cetera. But more generally, beyond conversations and beyond the privacy issue, there are other spoken language processing ethical and social issues. People should know when they are talking to a conversational agent. The Turing test is a fun challenge, but that's not the problem we really want to solve in conversational systems. In addition, Architectures and learning strategies for language technologies should work for different languages. Note that prosody is used differently in different languages, and so the mechanisms have to be learned from data. So a lot of the frameworks may still transfer, but a lot will need to be learned from data. Systems need to serve a diverse community of users. That diversity, such as age, dialect, cultural differences, impacts word usage, it impacts prosody. There are issues of bias in machine learning if you don't have diverse training data. On the other hand, user modeling, one must be careful about because you don't want to reinforce stereotype bias. And lastly, again, there is the issue of data. Since users can delete their data, that limits reproducibility. So in summary, I'd like to close with my few take-home messages. First of all, spoken language is not the same thing as noisy verbalized text. There are a variety of differences, and some of those differences, like disfluencies, actually, even though they're noise for language processing, carry information for dialogue systems. When we're applying natural language processing to spoken language processing, we can benefit from written text. So we have shown that with fine-tuning, you can, and other pre-training, you can improve parsing. And I'm sure that people have benefited in other applications as well. Still, there are pretty big differences between speech and text. And so further pre-training on spoken language is useful. And we've seen this in conversation, in call center conversations. Secondly, multimodal integration of prosodic cues with text is an important direction for improving understanding. It brings challenges associated with the temporal alignment, but also with the representation learning. And we've made some suggestions here about ways you can do different representation learning, but it's a fertile area for future research. If we move to conversational systems, we need to throw in speaker and dialogue state tracking both. We can't just track the dialogue state. And lastly, we need to do the speaker tracking because of user differences. And that impacts the dialogue policy, but it also impacts evaluation and makes that a much more challenging problem. Finally, spoken language processing research needs to be informed by and drive work in privacy and responsible machine learning. Thank you for your attention.
Thank you, Mari, so much.
Thank you. I'd be happy to take questions. I think you need to allow my video. So for one question, how much of a problem people's accent for this type of analysis? That's a great question. For speech recognition, there's been a lot of work looking at accent, and I think there's good progress that is made in that. It's important to train with a variety of accents. What has been less well studied is the effect of accent on prosody. And I think that it's clear that prosody is used differently in different languages. And so as a result, accents would be expected to impact the prosodic features. And so that's it. So definitely the systems are sensitive to it from a recognition point of view, from a prosody point of view, and lastly, from a wording point of view, because of code switching, which would tend to occur in things like that. So it makes everything harder. So there are, you know, having more data will help with working on this, but I think there's a lot of questions, research that'll still need to be done. Next question. If I understood correctly, I think you state that in many applications, e.g. speech translation, prosody is often not a critical feature for a lot of samples. This means that systems tend to ignore it as it is an information which is useful only to disambiguate few cases. I'm wondering if there are corpus dedicated to samples where prosody is critical. So let me clarify a little bit. I think in a lot of past work that has been on read speech, prosody has not been so critical. So when we talk about conversational speech or spontaneous speech, even spontaneous speech in podcasts, there's going to be more information that's possible from prosody than people have been able to take advantage of in the past, because the focus was on read speech. That said, I am still saying that there are fewer examples where prosody matters. The words matter more. I think that it's, I'm not aware of any corpora that are specifically designed to emphasize this, but I think that it is also very task dependent. In conversational speech, I noticed that it matters a lot more. Another issue that has caused prosody to seem like it matters not so much is the fact that a lot of work has been done with known sentences. Once you take away, so a lot of the switchboard work, including some of our own, but not all of our own, has been based on hand-marked sentence boundaries. So if you do parsing with hand-marked sentence boundaries, you're not going to gain as much as if you force the system to actually use the boundaries, to learn the boundaries and recognize the sentence boundaries. So I think as people start to solve the whole task, prosody will become more important. Same is true as in dialogue act tagging. Most people assumed you know where the dialogue act boundaries are. In fact, if you don't, the problem becomes much harder and prosody is going to matter more. So, so sorry I can't help you with a corpus, but I would say many of more recent collections that people are looking at that aren't constrained with hand-marked sentences would have a lot more phenomena of interest. Okay, next question. I'm just looking at these in order, so if any of the monitors wants to alert me to something, then I'd be happy to do that. Next question. I have some recent papers. I've seen some recent papers claiming that audio data can leak personal and demographic information to a greater extent than text. The approach this paper suggests is cross-training another classifier that attempts to breach privacy and penalizing their representation encoder based on that. Do you think this is a live issue, and have you seen other interesting approaches? This is definitely an important issue, which is one of the reasons I brought it up at the end. Audio data can definitely leak personal information because people can run speaker ID on it. And even if speaker ID isn't perfect, you can extract information reasonably reliably about gender, regional accents, etc. So to some extent, people have claimed you can get a little bit of age information, not so accurate on that. But yes, it can definitely leak more information than text. The approaches that people are exploring are just a start, and I think that there are going to need to be approaches, both based on the audio representation and based on encryption and various, and based on new methods of machine learning. So I think all different directions are going to be important, and I can post on the Slack a very nice survey about privacy that that describes some of these different issues. Okay, next question. How do we implement privacy-sensitive speech processing systems? Would this involve randomizing and/or synthesizing training data? Similar topic, and again, I'll say this is a big research issue right now, very important. Randomizing is helpful. Synthesizing training data, people are looking at, and that's I think a great direction. It's all open questions with a lot of different people working in this area, which I think is important. Is emotion in the speech a problem for these types of systems? Absolutely. Speech recognizers have higher error rates when the speech is emotional. Aninenkova did a nice study showing this with multiple commercial speech recognition systems. And so that is another source of variation that explains why systems are not perfect. The current systems are not perfect. So it is a direction where things need to improve. Okay, does the work with accents can help with the speech recognition of people with speech disabilities? Do you believe data from one can help the other? That is an interesting question. I don't know the answer. It would certainly be good to look at that. There are commonalities in the notion of speaker adaptation. So as we learn to do a better job of speaker adaptation, we should be able to adapt to different, both to different accents and different speaking, speech ability issues. I'm a little skeptical. I think that adaptation techniques vary depending on how different you are from the target. And so if your accent affects things, you know, if the accuracy is pretty high, the speaker independent accuracy is pretty high already, then the adaptation should work quite well. When the accuracy is horrible, then we may need more new methods for adaptation. And for some types of speech disabilities, they are very difficult to understand, and having more specialized either learning strategies or corpus collections will probably be helpful for that. A good area for future work. Next question, selecting domain-specific corpora is a hard task in spoken language understanding. Does speech synthesis be used in this case by data augmentation, like adding noises to them? This is something that people are exploring. I think it's, as speech synthesis gets better, it's, you know, you can get more speaker variety. I think speech synthesis isn't there yet in terms of getting the sort of speaker variety, particularly for conversational speech. Speech synthesis is really more, where it's good is short passages and reading style. So that's where the really good speech synthesis is available right now, and not for a huge number of voices. And so it's a great direction to look at for the future, but we need advances in speech synthesis as well in order for that to be an effective solution. Okay. When multilingual people mix words while having a conversation, will this be an issue or not English words are just discarded while analyzing in these types of systems? I think that this is an issue, and it's a mistake to discard these types of words, non-English words, because that's the person is communicating information through their use. In the same way, I think it's a mistake to totally discard disfluencies because there's some information communicated, but even more important, the non-English words are often content words that are really critical to the discussion. So I think they do need to be modeled. It's a harder challenge with some of the character-based models and language processing that becomes easier. It does make challenges for audio processing. Okay, I think I got them all. Is there anything?
I think just a huge thank you from all of us. Thank you.
Thank you so much, Mary.
Thank you.
Lisbon. Yeah.
Yeah, sorry I'm not there in person, but another year.
That was great. Fabulous. Thanks.
Okay, bye.
Bye-bye.
Right. So people that are still here, don't leave, because we are presenting the closing remarks now. So we are just preparing the slides.
Let me connect. Okay. Slides. Okay. Send. Okay. Can you see the slides? Okay. Perfect. So this is in name of the entire organizing committee, which actually made all the work, including preparing these slides. As is the usual tradition, even though we're doing this remote this year, I'm going to basically do karaoke with the slides because I don't know part of the content. This is something that last minute has been prepared by Fernando and Bruno, who usually do these things. And let's see how this goes. So as many years since we started the school, we are proud to have a very varied set of students from all parts of the world. The fact that we did this remote changed a bit things. We had a bit more attendees, right? I think this is a new record in terms of female attendance, if I'm not mistaken. It's something that we take very seriously. And 41 feels like it's the highest number we have for female attendance in the history of the school, which is awesome for the 10th division. I think industry is a bit below, but it's normally on normal numbers, right? As obvious, like Portugal seems to get a lot, and we normally get a lot of people from Europe. I was hoping, or we were hoping in general, that the fact that this is remote will get people more for around the world, but we seem to get, probably for word of mouth, we still have very much an Europe-centered, or maybe some American, Russia kind of audience, right? So this is another picture, a bit in a nicer view of the things. I would say related to other years, we do have a bit more of international expansion, right? Normally there is this problem with traveling, grants and stuff like this that limits a bit the attendance. So this year improved a bit. So there's, as always, remarks. Every year we get propositions to cover topics, different topics, remove this, don't put that. We understand that the labs and the code can be definitely improved. We move things every year. This year was a bit more complicated due to COVID and everybody being at home, and not everybody, including me, are in the position to do very large changes, but we have taken some notes and we definitely have interesting directions. I think the entire virtual thing went okay, right? It worked. Like we were all very scared in general, and I think we all have fun. We lost part of the social component. We couldn't go drinking in Barrio Alto. That's really something that you have to do anyway. So that's a good, so still come to Lisbon and have a party, but it kind of worked more or less. I think we got a reasonable interaction. So dividing a bit into the different components, right? Lectures seem to have worked very well. The fact that we could stream to YouTube and have also the Zoom seems to have worked. We know also from the amount of views that there were a lot of external viewers, that I think because this time we make more publicity about the URLs, there was a lot of people even outside of the school that watch everything. The feedback in general is very good. There's some requirements, like what people would like to see more real life examples, the relation between the talks and the lectures. This is very complicated because we start giving you the fundamentals, right? This is a school of fundamentals, of learning the pieces inside of the black box, right? And then most of the talks nowadays are about deep learning, which is a very advanced topic. And it's very hard for us to basically compose it in a way that on the first day you have a talk that's about basics, right? We normally have like a very high profile researcher with the best paper, and these normally are topics that are advanced. So it's always hard to equilibrate this. I don't think there's a bulletproof solution for this, but we can try to strive to improve this, right? And in general, the numbers are overwhelmingly positive about the talks, and I think that are even better than other years, which is good. So regarding lectures and practical talks, yeah, so people prefer pre-recorded lectures. I think most of the lectures were pre-recorded, excluding Viksha and Jonas, right? I think it also gives the speakers the opportunity to see themselves, and I think it gives them more time to think, right? But it loses a bit. I think Viksha managed to have people interacting a bit more, and I think that also reflected in the positive feedback of his lecture overall, right? It's a bit divided. I mean, I think that both formats have advantages and disadvantages. We like both actually, but I think pre-recording is less scary because you have a thing there. You know the audio quality is good. You know the resolution is good. You know the connection will work, right? As long as Fernando very nicely has been the main hub for projecting things, as long as Fernando's computer works, everything would work if it's pre-recorded, right? Labs got in general very good remarks. I think for me, the last part were very scary because it's not the same, really, like having it remote. Of course, people don't finish exercises. Don't feel guilty if you felt a bit overwhelmed. It happens every year. There's an enormous amount of content. You can see this as a number of pointers, right? Pointers in directions that you can progress. But don't feel bad if you weren't able to finish. It's true that it starts very easy. You're asked to do Python, and you say, okay, I know Python, this is easy. And then linear classifiers is okay. And then suddenly, if you never saw HMMs, it gets a bit scary. And then at the end, you get hit up with reinforcement learning, right? So but it has been always like this, and you could see it as something that you can always revisit. The theoretical fundamentals in the guide are very nice, very detailed, so you can always think about going back to this. Ratings of monitors were very positive. It has been a bit weird to organize this remotely for the monitors team, but I think overall it has worked quite well, right? The virtual rooms, moving people, getting people to interact has been complicated. Other years, people just go to drink coffee, and we have a lot of interesting conversations. This didn't work as well, and in general, people are happy with the guide. Which is good, but we always found some bugs. There was some typo in one day, so we will be correcting those. About remote facilities, Zoom, everybody used Zoom, of course. YouTube, probably for people from outside as well. We found something curious, which is like 80% of the messages in Slack were private. So we suspect people had been talking to each other outside of the public channels. I think the Gather Town needs people to be more convinced about it. I think it's a very cool idea. Maybe, at least from our side, we haven't managed to exploit it fully, and hopefully we don't have to use this in the future, but it's definitely something that That can be interesting. The Zoom in the labs, we wanted to have less people in the Zoom, basically. When there's too much people, people are scared to speak, right? And if you're with 50 people, you don't want to be the one that asks about an exercise. Whereas if you're in a small room, that works much better. We're keeping Slack, for sure. Like Slack really worked, and we're keeping it for coming years regardless. I think it's a very nice tool. We have to still figure out how to, a lot of people ask, can we keep it open, right, to keep contact? Logistically, if we open a Slack every year, that can get a bit troublesome. So we have to think this a bit better, but definitely Slack made the experience better, even if we're going to have an on-site school that's going to be there. Overall, we got very good scores. We normally get a bunch of suggestions, improvements in the labs. The other machine learning topics is a constant every year. We normally have a lot of discussions, and we have shift over the years the topics, but it takes time. Transformers, definitely, it's obvious the elephant in the room. Social activities, I mean, this hopefully next year will be completely different, right? We could also have had poster sessions online if we were more confident. So, but in any case, we want to thank you all for the suggestions. Keep it coming. Send more emails, send personal emails, whatever helps you to give more feedback. So as always, you know, this is only possible because these very generous sponsors give us money to, you know, this basically runs on the generosity of our sponsors that pay for the different parts, including the licenses for Zoom and things like this, right? So we would like to definitely use this opportunity to thank them. Of course, this doesn't work without the amazing set of speakers that we have, which is one of the fundamental assets of the school. There are some that come every year for 10 years, some that are new, some that come from time to time. And it's definitely what makes us a great school is the amazing value that we can bring on to lecture, right? This year, we had this panelist idea that I think from the feedback was very positive. And we would also like to thank the panelists. And hey, maybe some of you in some years come and form part of a similar panel, right? We're looking forward to revisit this in the future. Also, the monitors team, I would personally also like to thank them. The fact that they overcome the difficulties of working remote, and we know that when you work remote, you have other things to do, and there's a lot of things moving in the house. So it's really good that we managed to deliver, even though we were remote. And of course, we would like to thank you all for sticking with us and trying this adventure, which that we think went relatively okay. And we're in general happy with the output. And normally at this point, people will react, but I don't see your faces. So I'm just going to end this here. And well, thank you very much for attending the school. Enjoy your flight back. Oh wait, no, there's no flight back. So just enjoy staying in your room. Okay, so Fernando, do we want to maybe we want to meet at GatherTown? Do you think that that's a? I would happily join GatherTown now if some other student is interested. What do you think the other organizers would be in for small virtual session?
I think it's a great idea to conclude the school. So
I don't
yeah,
hear you, Andre.
Can you hear me now?
For some reason.
Can people hear me?
Maybe it's
yes. Okay. Yeah, so I would suggest that everybody takes a chance to go to GatherTown if you can. It's a good way of concluding the summer school. In any case, thanks everyone for attending. I think it was a very good experience. Well, for us as organizers, we had a lot of pleasure doing this, even though it was remote. I think it went out pretty well. So I hope to see some of you now in GatherTown, and I think this is it. We have nothing else prepared. All right, okay. See you guys in a bit.
See you there.
Bye.
Bye, thank you.
Bye-bye.